Go ahead and start. It's recording. So what we want to do is, if you saw the steps 1 and 2, you pick two equations that you want to scan this and see what am I going to eliminate. And if you look at this, you see quickly that I can eliminate a y, right? Because I have two negative y's and a positive y, all coefficient 1, so that's what I'm going to eliminate. So what we want to do is, I'm going to label this 1 and 2 and 3. So there's my labels for my systems of equations. Now I'm going to start with equation 1 and 2, and I'm going to eliminate my y. So I'm going to take x minus y plus z equal -1, and x plus y plus 3z equal -3. Okay, so we've got equation 1 and 2, and we're going to combine them to eliminate our y. So if we add the two equations, we get a 2x, the y's go away, plus 4z equal -4. So now we want to stop there, and we want to call this equation 4. Okay, and I'll highlight that with yellow. Now we want to do the same thing using the other equation that we didn't use. So we've done 1 and 2. Now just look at your coefficients. We've got a -y, a positive y, and a -y. Well, we used 1 and 2 already. So now we've got to work on equation 3. It's a -y, so I would use equation 2, because if we add equation 2 and 3, we're going to eliminate y again by just adding. So let's do that. So we're going to take x plus y plus 3z equal -3, and 2x minus y plus 2z equal 0. Okay, now when we combine these by adding, we're going to get 3x, and the y goes away, plus 5z equals -3. Don't drop your sign on the negative. So now this becomes equation 5. Now we've eliminated one variable out of our 3. Now we've got to eliminate one more to get it down to one variable and solve. So we're going to take our equation 4 and 5, and now we're going to combine those to eliminate yet one more variable. So we get 2x plus 4z equal -4, and we're going to add to that a 3x plus 5z equal -3. So can we add or subtract to eliminate any variable? No, we cannot. So what do we have to do? We're going to have to pick a variable that we want to eliminate. I'll use x, and we have to make a common coefficient, so these will eliminate. So the first thing I'm going to do, it would be a 6x, correct? So we're going to have to multiply the top by a 3, and we want the bottom to be a -6x. So we're going to multiply everything by a -2. So let's do that. So on the top line, we're going to do 3 times 2x is a 6x, and 3 times 4z is a positive 12z, and 3 times -4 is a -12. Now for our bottom equation, we've got -2 times 3x gives us a -6x, -2 times 5z is a -10z, and -2 times -3 is a positive 6. Now we can add these two equations to eliminate x, and we get 2z equal -6. So now we can solve for z. So we get that z is equal to negative 3. So there's the first of our equation. So I'm going to go back up here. So we're going to have an x, a y, and a z, which is negative 3. Okay? And our next step now is to plug this negative 3 for z into either equation 4 or 5 and solve for x. So I will pick 4. So 2x plus 4z equal negative 4. 2x plus 4z equal negative 4. And we're going to plug in a negative 3 for z and solve for x. Alright, so we get 2x minus 12 equal negative 4. So 2x equal an 8. So x is equal to 4. So now we've got our second variable solved. So we've got 4 for x and negative 3 for z. Now that we have two variables solved for, now just pick either equation 1, 2, or 3 and plug in your 4 and negative 3 and you will get your y solution. So let's pick one. And actually now I'm going to erase part of this since we don't need this anymore. And I'm going to work right here. Alright, so I'll pick equation 1. So I have x minus y plus z equal negative 1. That's the easiest one to work with, right? So we know that x is 4, so plug in a 4 for x, minus y, that's what we're solving for, plus z, which is a negative 3, equal negative 1. Okay, let's erase some more there. Okay, now I'm going to combine my like terms. 4 and negative 3, that equals a 1. So we have 1 minus y equal negative 1. Now just solve for y. So subtract 1 from each side and we get a negative 2. So we have negative y equals negative 2. So y is equal to 2. So now we have all three variables solved for, and that is the solution to our system of 3 variables. It is 4, 2, and negative 3. Now how do you check these? You plug 4 back in to each one, equation 1, 2, and 3. So 4 for x, 2 for y, and negative 3 for z, and all 3 of these should make a true equation. And that's how you solve a system with 3 variables. Thank you.